Cambridge International AS, May-June 2024, Paper 22. Question 1. A. Complete Table 1.1 using relevant information from the periodic table. Magnesium 2 plus, aluminium 3 plus. The nucleon numbers are given 24 and 27. We need to figure out the proton number and number of electrons. We know that the proton number for magnesium is 12 and for aluminium it's 13. Now, to figure out the number of electrons, we have drawn the electronic configuration of both. From here, we can see that both contains 10 electrons. For magnesium 2 plus, we have to remove 2 electrons from 12, so we will get 10. For aluminium, 13 minus 3 is equals to 10. So both are isoelectronic and both of them have same number of electron shell. B. State and explain the difference in ionic radius of aluminium 3 plus compared to magnesium 2 plus. Here the ionic radius of aluminium 3 plus will be smaller than that of magnesium. Why? Because both has same number of electron and same number of shells in it. So they are isoelectronic and will have same shielding effect. But the only difference is in the proton number. Aluminium has higher proton number. Therefore, it will have greater nuclear attraction than magnesium. So, therefore, aluminium has greater nuclear attraction for the remaining electrons and the ionic radius will be smaller for aluminium. C. Draw a label diagram to show the structure and bonding in sodium. Sodium is a metal. It will release the outermost shell electron as delocalized electron and it will become positive charge. So here is the positive charge of sodium plus and these are the electrons in the sea of delocalized electron. D. Figure 1.1 shows the variation in melting point of some period 3 elements in their standard state at room temperature and pressure. Here is the melting point for sodium, magnesium, aluminium and silicon are given. We can see that from sodium to silicon it's increasing. From sodium to magnesium it has increased. From magnesium to aluminium it has increased a little bit, but from aluminium to silicon the melting point has become much higher. 1. Explain why silicon has a high melting point. Silicon has giant molecular structure and the structure is just like the carbon in diamond. It has tetrahedral geometry. One silicon is bonded with 4 other silicon atoms. So large amount of energy is required to break these covalent bonds in silicon. That is why the melting point of silicon is much higher compared to sodium, magnesium and aluminium. 2. Complete figure 1.1 to show the variation in the melting point of the elements phosphorus, sulfur and chlorine. Let's get back to the figure. So here we have to draw the melting point for phosphorus, sulfur and chlorine, which are non-metals. So here from silicon to phosphorus the melting point will decrease and the melting point for phosphorus will be lower than sodium, and from phosphorus to sulfur it will increase and the melting point for sulfur will be very similar to sodium, and from sulfur to chlorine it will decrease again and the melting point of chlorine will be lower than phosphorus. So we have to follow this trend. But why it is like that? Phosphorus exists as P4 molecule and sulfur as S8. So, between phosphorus and sulfur, the melting point for sulfur is higher because of its larger size. And chlorine exists as Cl2. So, normally two chlorines are bonded together and forms chlorine molecule. So, it is much smaller than phosphorus and sulfur. So, because of its smaller size, the melting point will decrease again. E. Two period 3 elements reacts with an excess of oxygen at room pressure. 1. Complete table 1.2. Table 1.2. Period 3 elements sodium and sulfur are given. State of oxide at room temperature and pressure. For sodium, the oxide is Na2O, and at room temperature it is solid. For sulfur, which is a non-metal, the oxides are sulfur dioxide or trioxide, and they exist as gas. Approximate pH of solution made when oxide is added to water. So when sodium oxide is added to water, it gives sodium hydroxide, which is a base, strong base. Therefore, the pH will be around 14. And sulfur dioxide reacts with water and gives sulfurous acid. Sulfur trioxide with water gives sulfuric acid. Both of them are strong acid. So we can write 2 for its pH. 2. The solutions made in column 3 of table 1.2 are mixed together. Name the type of reaction that occurs. So here we are getting a base and an acid. So we can write it will be an acid-base reaction. Write an equation to describe the reaction between P4O10, which is a phosphorus oxide, and an excess of water. So here is our phosphorus oxide and water. It will give phosphoric acid, H3PO4. Then we just need to balance the equation. F. Aluminium hydroxide is amphoteric. Explain what is meant by amphoteric. So till now we were dealing with oxides of metals and non-metals, but now they have given aluminium hydroxide. So what is amphoteric means? Compound that reacts with both acid and base are called amphoteric. 2. Write an equation to describe the reaction that occurs when aluminium hydroxide, AlOH3, reacts with sodium hydroxide. We have already know our equation between aluminium oxide and sodium hydroxide in water, which means aqueous solution. It gives sodium tetrahydroxoaluminate. Now we will deal with the hydroxide of aluminium. So aluminium hydroxide with sodium hydroxide gives the same compound, sodium, aluminium and 4-hydroxide, which is sodium tetrahydroxoaluminate. We know we have a test in paper 3 for metals. We add sodium hydroxide in metallic compound dropwise, and it will give a precipitate. Like for aluminium, calcium, it will give white precipitate. And if we add excess of sodium hydroxide, then the precipitate, in case of aluminium, the precipitates will dissolve and will give a colorless solution. So what is happening? In an aluminium compound, if we add sodium hydroxide dropwise, it will form aluminium ion and will give white precipitate of that aluminium. And if we add excess of sodium hydroxide in it, then it will dissolve and will give sodium tetrahydroxoaluminate, which will be a colorless solution. So that is a aluminium test.